Hello, and once again, I felt I had to squeeze in a telescope astrophotography video catching the only clear night available, since the next 5 days are forecast cloudy. And even then, you never know if the weather will hold up during your night sky outing. Anyway, this episode is focused on the use of a Schmidt-Cassegrain telescope doing astrophotography with eyepiece focus to the mounted camera, and the general use of this particular scope, the Celestron NexStar 8i Special Edition. It's the immediate predecessor to what Celestron renamed the NexStar SE, which has the identical altitude azimuth electronic movement and hand controller system. The main difference was the 8i model did not have an adjustable bracket to allow the telescope tube to be moved upward to give more space underneath when switching to a 2-inch diagonal and eyepieces. Therefore, a fellow named Ray came up with what were called raised brackets, which served this purpose, and turned the 8i Special Edition scope into the SE scope, effectively. So a shout out back through the years, to Ray. And if I may say, my 8i Special Edition has lasted through the years quite well. I happen to have set up my NexStar 8i with a larger finder scope good for aiming, and a green laser with a nifty push button on-off switch for pointing to the sky object desired, but it was also sold with the star pointer, which has an adjustable brightness red dot for lining up the scope with the heavenly object. The main feature of the NexStar 8i is the electromechanical movement with a hand controller by which you align your telescope with the sky for tracking, for locating and slewing to objects in the night sky, and other functions. This is identical to the newer NexStar SE, which is still on the market. One of the bigger features used with the hand controller is called SkyAlign, which is a 3-star system to supply the telescope with the current position of the sky above it, so it can then begin tracking objects up there, as the Earth moves beneath. Tracking is very useful for visual and photographic work, especially if you intend to do long exposures. But tonight we're just showing the basics. The current date and local time, and your latitude and longitude coordinates are entered and verified. The SkyAlign process is performed by slewing your scope to 3 stars in a triangular position in the sky, then you are good to go. In our last video, we did some astrophotography with a prime focus mounted camera on my Trust Ob scope, so this time, we will instead see how use of your favorite eyepieces can be done, projected to the mounted camera's CMOS sensor, with no other camera lens. Featured, we will be using a handy piece of equipment called the VariMax II, which allows for eyepiece projection. And I'll show in the video what the difference is between a prime focus mount, and the eyepiece mount method. As usual, I first like to perform some preliminary checkup and focusing work, especially with new equipment, during daylight hours to ensure things work as expected. First, we show the difference between prime focus camera mounting versus the VariMax II mount for use with eyepiece projection. Next, I attempted focus on a distant microwave radio tower 4.9 miles away on top of a mountain during the day. First with prime focus. Then using the VariMax II unit to hold a 42mm, 32mm, then 26mm, 2-inch format eyepieces. The photos show the results in each case, so it could be applied during night shots. This ensures that in the dead of night and darkness, focus on infinity can be achieved, as needed when looking at the stars and planets. Finally, I settled on using the 32mm eyepiece for the night viewing. The evening of the astrophotography session, I intended to capture images of Jupiter, then Mars, which was at about 75 degrees altitude that night, and the Orion Nebula to the south of Jupiter. I ran through the sky alignment process, locating 3 bright stars, and ending up on Jupiter as my last object, and SkyAlign completed successfully and began tracking on Jupiter. Here I have grabbed a few snapshots of Jupiter and its brightest moons with higher ISO and quarter to half-second exposures with the Nikon Z. Then it happened. Through the local weather indicated clouds before 5 a.m. later that night, already at 10 p.m. the clouds started rolling in quickly from the west, obstructing my view of Jupiter and any potential to see Mars above. So I just slew the scope up to the moon that was most conveniently still visible to the south. And while hazy clouds were beginning to obstruct it, I took a few shots of the moon before the clouds got worse. Anyway, if you did have more good weather, more objects can be observed while the NexStar telescope hand controller has it tracking sky objects, and you can select from the database of objects in the hand controller to locate for you in the sky, and it then slews to that object you want. Unfortunately, my night sky watching this night was called off by the cloud cover that came about so quickly. But this video was mainly about the use of the VariMax II eyepiece projection photography method. Hope you enjoyed this video, and please like and subscribe to our channel to help us present new videos on this and other subjects. Thank you, and please tell others about us. Happy sky watching!